No other time in the building history do we have a better understanding of what we built and what we can build. Home Building Crossroad can be a way for people to understand that our goal is to put a house in a position for success.
Welcome to the Unbuild podcast. I'm Jake Bruton. Today I am joined by Peter Yost.
Hey!
And Steve Basic.
Hello, everybody.
For those of you listening, Steve's adjusting his
thinking cap on.
United States Marine Corps hat.
I'm wearing it in protest if you heard the above grade walls.
He's forgetting that these are publishing weeks apart potentially, and everybody else has forgotten.
Go listen to the above grade walls and listen to how Jake bashed our military in protest.
And it starts with that, and if I don't defend myself, it's just that. It's just, yeah, Jake must have said something poor about the military. And so this is number 3 in a little mini series of podcasts that we're doing
a
here.
mini series, I love it.
It's like a series.
I've never been in a miniseries. Have you been in a miniseries? I've never been in a miniseries.
No Lifetime movies for you guys?
This
Like
week
mini
on
me,
Lifetime.
Meredith Baxter Birney.
I had a friend that was in a movie. I did have a friend.
And so now how many people have clicked off to see something else? You know what? I am going to watch that thing about people dressing their dogs up like bumblebees.
I don't know where you get this.
You should visit bdogs.com, by the way. I don't know if it's still up, but that was my favorite website for many years. Today we are going to talk about roofs.
Woofs.
Woofs. Roofs?
Woofs.
Roofs.
Bumblebee dogs and woofs.
The roof.
The woof.
Steve, get the reference there, Peter.
The roof is on fire.
Wow. Okay.
I'm not quite sure who to look at right now because you're both totally off the wall.
So we talked.
You're off the wall and onto the
above the
roof.
wall.
I get it.
We talked about below grade. We talked about above grade walls, and now we're going to talk about how we cap off, how we finish, how we terminate at the top.
Yeah.
And so, where does this conversation start?
I know exactly where it starts. To vent or not to vent. That is the decision.
I'm going to say no, it's not. Let's just vent it and be done with it. Can we stop arguing?
I'm not
about
arguing. Who's arguing? I wasn't arguing.
It's an easy one for me. I mean, you and I agree on this completely.
Yes.
We vent as much as we possibly can.
Vent until you can't vent.
Yep.
Is what I always say.
And then when you can't, do it wisely. Good design prevents problems to begin with.
That's the very shortest
Thanks for listening.
we've ever had.
Thanks for listening today.
All right. Hey, that's a wrap. Great job.
So are you saying that we vent attics or vent roofs or vent both?
I would like the
Whenever
back
you
side
can?
of my roof sheeting to be ventilated.
You would like the back side of your roof to be ventilated. Okay, so that means that you're trying to increase the drying potential. But
So even in a cathedral ceiling, I'm still venting that assembly if possible.
But so we jumped at the very beginning of roofs to protecting them from getting wet and helping them dry. So aren't we starting at the very end of our 4 control layer approach as opposed to starting at the beginning?
Water management's the first one. We're managing water with that. It just might be in a
You're
different...
being sneaky.
That's a stretch. He's being sneaky. I'm with you, Peter.
But
Military bashing.
as you know, when we were talking about foundations, we said all these conversations that we're going to have are after the thing doesn't fall down. Code or your engineer is going to keep you from making it fall down. All of the conversations we're about to have about roofs are, well, this is after the fact that it is properly sloped, properly drained, and the shingles or the metal or whatever the roofing material is properly installed. Obviously, right? Like. It seems silly that we would have the conversation start at that point, but okay, there's no holes in it that are leaking. Now what do we do with a roof? Right?
Yeah, I agree.
Okay.
We're in the business of not building leaky roofs, obviously.
Okay, good. I like
Right?
it.
So water management is a given when it comes to roofs.
And when we talk about water management, so this is all climates, all slopes, all configurations. We're gonna make sure that we bulk water manage, and there's not gonna be any air leakage. And we're gonna add drying potential by venting. Okay, I'm with you.
Which
right there.
Is that not the same conversation we
Well,
had
we
about
have some
walls?
air leakage because in the roof attic assembly, we want to make sure that our conditioned space is inside the air barrier or our air management system to the attic. So we don't want the attic to communicate with our interior conditioned space. So we do have a barrier there,
Unless we're doing a conditioned attic.
unless we're doing a conditioned attic. But if you're doing a conditioned attic, you still have a barrier system. You just moved it from the flat to the slope.
Yep. So it's actually one of those things that, like, we have this conversation with people that build in the South all the time. They're just like, no, we open cell foam the whole thing, you know. And, okay, but why wouldn't you still just go ahead and include vent chutes on the top side of that and have a vented assembly and a cathedral ceiling that you didn't put drywall on? Because that's my cathedral ceiling, is an insulated vault that has vent chutes on the top side of it. So I have a vented space, the code minimum.
Obviously, you haven't been to Dallas.
Well,
Because the problem is those roofs aren't
it's not a peak. It's
you
not a
drive, you
gable.
drive around Missouri and everything is a straight gable for 40 feet, and there's a gable end and 2 eaves on a ranch. So it's pretty easy. But the minute you introduce all these kind of traverse type roof frames into that gable, and it's a 9 and 12 and the house is 40 feet deep, it's a totally different roof system that
sure.
just putting roof channels up through there, you're going to run into some
Valleys
hips
and
and
hips
valleys and it's going to become
So maybe we should stop building
problematic.
disgusting looking houses too.
Yeah, well, we should just do that anyway, I think.
So there you go. I problem solved a building science problem by asking architects to not decide to have 35 different roof lines.
You are a problem solver, I'll give you
Thank
that.
That's what I do.
I'll throw it
And it's interesting, connecting this back to the below grade walls, I said that one of the first things I go and check about water loads that the foundation sees is looking at the roof plan. And I mean, if you're looking down and it takes you 5 minutes to figure out where all the water is going, it's probably a pretty complicated roof plan.
You know what's pretty interesting about that comment?
Nope. Tell me.
Okay, good, I will. Years ago, as a young architect, I learned early on, and I learned it obviously the hard way, but that's how we learn a lot of our lessons in life. But the minute you draw a floor plan, you need to step away and say, how do I put a roof on it? Right? Because one of the things that I get client sketches, and it's real easy to kind of disregard them because 99% of the time you look at the client and say, okay, I get it. The floor plan looks good. Let me just ask you a really quick question. How do you put a roof on that?
It's a 90-foot long flat roof from front to back. That's the
Yeah,
only
pretty
option.
much. Like, it's 60 foot square and it's just a flat roof that, we do it. But yeah, it makes sense. Like from a building science perspective, you look at the roof plan and say, where does the water go? And the same thing I look at a floor plan when I'm designing a building and say, where does the roof go? How does the roof go? Right? There's a lot of things that have to make sense. Like I just worked on one and building the model, and I kind of broke my own rule, but the main body of the house was 26 feet. The section of intersecting body of the house was 24 feet. So when you bring the roof up, if they're the same pitch, this main roof sat 9 inches above the lower one, and it gets that little triangle. So now I have to sit there and say, okay, do I raise these plate heights and push that roof up? Do I change that pitch to a 10 or a 12 and get it steeper and higher up? And now the eaves don't really match. So there's this interplay, but it's, when it comes to roofs, there's a big interplay. And from an aesthetic point of view, the roofs can really make a house or break a house.
Yeah. And Steve, when you're working on these configurations, do you use SketchUp to sort of get a sense of the 3D?
Yeah, all the time.
Yeah.
All the time.
Yeah.
And what I use SketchUp a lot for is I'll build the roof in 3D, and then SketchUp, I have the ability to transfer that to a 2D drawing. So I can take that, because some of them, when I was doing work for like Paladura and Artistic, like we would go into communities that had covenants that required, like, the roof had to have a minimum of 7 planes facing the street.
Good
and the
Lord.
front elevation had to have a minimum of 5 different planes. 3 of the planes had to be more than like a 2-foot.
Are you serious?
That's
They
disgusting.
have requirements.
Yes, there's
I have
covenants
never-
in
have you ever heard of
communities.
That is the worst architectural review committee probably in history.
There's,
No, I only count
listen,
4.
they'll publish a book, 30 pages on all the covenants. I mean, it'll talk about sidewalk and all of this stuff, driveway, doors can't face.
I'm flabbergasted. I've never heard that there was geometric complexity required.
No.
From the front.
And some of them require, like, I'm working on one now where they require a certain amount of stone to
Yeah,
face,
well, we get
or
those.
masonry
I
that
get
has to
that,
face
but
the street.
intentional complexity.
Intentional
in the roof plane.
complexity. You had to have
Wow.
a certain number of roof planes, and sometimes it was high, sometimes it was low. But some
I wish it was
communities want that broken up coastlining roof that goes everywhere.
That's when I wish that I was a billionaire and could just go in and buy it and just build the ugliest house. Just like, no, it has 7 roof planes. Just so happens that one actually drains back towards the house. That one, or it's a Buckminster Fuller geodesic dome. No, it has 65 roof planes actually.
There you go. But yeah, no, there are communities out there that have covenants of different roof planes, wall planes, and how much they have to be displaced. And
I motion to tell people to stop that. Anyone in favor?
I second.
Anyone wanna second that. Okay, thank you.
But yeah, but getting back to roofs, yeah, there's Joe used to do his famous crumple up a piece of paper,
Frank
throw it
Gehry.
on the table, and say, okay, how do I vent that?
Yeah.
It's like you can't vent that, right? And that was my reference to Dallas or some of these places that just have these complex roof systems that you really can't vent them. They become a challenge.
So we know that the adage that both of you follow is vent until you can't. Mm-hmm. And we had an interesting little experiment today in terms of, well, when can you vent or not?
Alert. Building science alert. Newsflash.
So
Because
the code.
no, we made history today.
We did. So
He's going to
let's
set the
set that
context.
straight.
the code says that you're not supposed to vent anything under a 312.
Right.
Like it says that like the recommended path is unvented assembly once we get below 312 pitch. And the house that we're building together is a 112.
It is a 1 in 12 roof, but it is a fully ventilated, cross-ventilated roof system, meaning that it is not only eave and ridge,
High to low.
but it is all the entire rake system is open, so
We would
that
call that omnidirectional.
omnidirectional.
And let's set some further context, which is there's a lot of rules about venting of attics and roofs that is based on ratios and numbers. Talk about great references. There's a great book by Bill Rose called Water in Buildings, where Bill Rose is one of our building science historians. We don't have very many of those, but he traces through the history in the 1930s and 40s of where we get these numbers for ventilation ratios. And he says, basically, we just sort of made them up. And so when we talk about rules for venting, a lot of it's not based on actually testing to see what kind of flow we get, because we know that what's the key is that we move air through that vent space to get drying potential. And so you, as a bold architect, said, we can vent 112. And I have to admit, it was like, I'm
Well,
not
what's
really
interesting
sure,
is,
Steve.
I mean, a couple of months ago, you were at my house. We broke out the tools and we played around with venting. And I have a two and a half in 12 roof that it vented perfectly well too.
It did.
So how do we test that?
Well, so that's a really good question, because you're looking at a wing nut, and the thing about a wing nut is that codes and rules and labs are not really that important. But what's important is that we actually go out in the field and see what kind of flow we can get.
When you brought this up, I thought you were going to convince one of us to like fart at one end, and everybody else was going to cram their face
No
against the
fart
ridge
jokes.
vent.
I don't like fart jokes.
Yeah, I don't know how we just got from being a wing nut to discussing farts. That was just like another really big leap.
Yeah.
But
Well, at least we're not bashing the military.
Holy smokes. Speaking of holy smokes, so
There you go.
the way
Good
we do
transition.
it
There we go.
is
We get a church candle.
better than the church. From the parsonage.
From the parsonage, we get a large
man.
Is it called the Pascal candle? Isn't there there's a name for like the large when you're at a funeral, there's usually this large candle that's at the head of the casket that we would
See,
light.
you were raised Roman Catholic, I was
Yeah,
raised
that's
Lutheran.
right.
We don't have
So-
the big fat candles.
I think it was called
We're
the Pascal.
Roman.
I was Roman.
Roman
Pardon me, Roman.
candle. Anyway, I digress. But
Hail Caesar.
yes, you asked me how can we measure the airflow, and I figured, well, let's take a theatrical fogger, let's jam a hose up into the soffit and see what kind of airflow we get from soffit to ridge.
Which is just
And-
visual air. You
Yeah.
just made the air so that we can see it.
Yeah, essentially. And so you and I have done some work on that together at your house. I've worked on other ones, but I thought, hey, we're out of Jake's house that Steve designed.
But when you did it, we're not pressurizing the cavity, so people know. We're setting that theatrical fogger underneath the vent and just blowing some theatrical air that is allowed to do whatever it wants to do. We're not jamming the pipe into the cavity.
Right.
I guess is my point.
We're not propelling the fog.
We're making it available.
We're making it available to the vent. But so in the past, what we've done is timed how long it takes the fog at the soffit to get to the ridge.
And just so you guys know, I'm kind of pissed that you had me in there doing window videos and stuff, and I missed the whole action.
You will
but-
get to see it on YouTube
Oh,
because
great.
we publish
Yeah, let me just watch
the
the
Unbuild
video.
podcast publishes
All right,
to
I'll
YouTube.
remember
And
that
you'll get to
next
see
time.
it. Good
Yeah,
plug.
whatever.
Good segue, Steve. Go ahead, Peter.
We have video to prove that we got a 30-foot run to vent in 10 seconds from soffit to ridge.
Well, tell the truth though, because I heard the real story from the people that were out there. You guys did the test.
Take one
Take
was not
one.
10 seconds.
It was so quick, you weren't even ready to video.
He was still talking to the camera, and it's coming out.
And it's
behind
coming
him.
out behind you. That's how fast it worked.
I didn't think it was going to go faster than 10. I was like, I wonder if this will take like 30 seconds.
Yeah,
Like,
exactly.
Will it go a foot per second?
We had to do a second take because the smoke went up the 112, the fog, much more quickly than we anticipated.
Yeah. So there you have it. I mean, this is. I know we take it lightly
but
and
verify.
Well, we take it lightly, but this is. I won't say historic, but this is really important. I mean, we physically tested a 1 in 12 roof and proved that in 10 seconds, air moved from soffit to ridge vent.
And so the other question is why? I mean, why did it move? And we know that the sun came out not long before we did it, heated up the roof, exaggerated the stack effect from high to low, and the wind was blowing. And so if we have a driving force, it doesn't matter that it's 112. We can move air through it. So,
And we should also note that the stack effect is how we're relying on all of the attic venting to happen.
yeah, and so
Which is why the steeper the pitch, the more it works because there's more of an elevation change.
well, and we know that we can have gable to gable vents, and the code allows that, but what's the driving force?
Right.
Yeah.
And not for
That's
nothing.
why-
If
that's
we
why-
did a 12 and 12 roof that was 30 feet long, I don't see the air coming out much quicker than 10 seconds. I mean, that was pretty
10's pretty quick.
incredible.
I haven't fogged anyone except for
One
that
of the
one.
questions I had that I wanted to discuss when we were driving back is, do you think the fact that it's a metal roof in lieu of an asphalt roof has any impact
That it
on it?
absorbs a little bit more heat.
Or if it's just a little warmer on the top side of that cavity to create an accelerated
Or it
stack
reacts
effect,
quicker too.
or-
There's less mass there.
So the whole reason we started this testing was to find out the factors that do affect the flow rate, because frankly, the code doesn't care whether you have asphalt roofing shingles. We know that the minimum depth is 1 inch, but we don't know. Well, is 3/4 okay, or is 1.5 inches
Well, in this case, we have 1.5 inches, so
Which we know is pretty good now.
which we know is pretty darn good.
And interesting, when I was talking to a guy at GAF, the technical guy, he put me in contact with a retired researcher for GAF who had over the years done a lot of testing, particularly on really long runs. And he said, yeah, I can't prove this, but over the years in looking at different depth of vent chutes, it seems like 1.5 inches is a bit of a sweet spot. And that's pretty cool because that's a 2x4. So the code says a minimum of 1 inch, but it turns out that there's some evidence that 1.5 inches is a bit of
a little better number.
Yeah.
So just to be clear, the assembly that we're talking about is truss frame roof with OSB on the top of it, perforated throughout, and then overlay of 2x4, and then a solid assembly OSB. It's zip sheathing in both cases, actually, and then fully adhered membrane. I think we use shark skin. It's a high temp rated, recommended by Sheffield, the manufacturer of the metal, and then metal roof. So it is a vented over roof.
Yep.
We didn't just vent a 112 truss assembly or anything.
So it's an OSB sandwich, if you will, right? There's two layers of, there's a layer of OSB, or do we use plywood?
We actually used 5/8 zip on both layers.
5/8 zip. So we have 5/8 zip and then 5/8 zip with the 1.5 inch in between, but the 5/8 zip on the lower has a whole series of you call them perforations, but they're like 4 or 6 by 8 inch communication ports, but it allows that air to communicate.
And our 2x4s are not totally continuous either.
And our 2x4s are not. So there's this kind of omnidirectional matrix that air in the lower layer of the attic can move about and go up any hole, but then once it goes up any hole, it's connected to the rakes, the eave, the soffit, and it can move. So it's kind of like, I would liken it to an open joint rain screen. Like, it's one of those things where if I give it the most amount of air, mentally you're going to say, oh my God, that's going to fail because you're letting all this water and air in there. But really what I'm doing is upping the drying potential. And so in this roof, I would say we severely upped our venting potential.
Absolutely. And it's interesting because when we think about comparing what are the drying potential needs for a roof as compared to a wall, well, it's pretty easy to argue that, well, the roof sees a lot more water than the wall does. So shouldn't we be even more careful about providing it with, a venting? And it's interesting in the assembly that you described, that vent chute is actually providing drying potential to both the top and the lower sheathing layer, right?
Yeah, it's basically a roof rain screen that we developed, right? It's basically so this goes back to our comments where we talk about Mother Nature and the semantics of building. There's floor assemblies, wall assemblies, and roof assemblies. We've talked in the past about taking our wall assembly and laying it down and using it as a floor assembly, or laying it down so that the insulating sheathing. Well, in this case, we've taken our rain screen system and rotated it to become a roof system. And Mother Nature's rules apply. If it works and vents there, then rotating it should vent too.
So we're looking at Roofs 101, and we've talked about the drying potential. One of the things that's interesting too is that it's one of the few places where there can be a serious separation between the water control layer and the air and thermal, right? Because they can, with an attic space, they can be pretty much totally disconnected.
It's also the only place that like our water control layer is discontinuous. Like if you do that red line test for water control, it's like, for me, it's a lot of times it's zip sheathing on the walls and then all of our foundation.
Yeah, the lines kind of extend and go up to the air.
Horizontal soffit thing that's not really water control anymore, and it's just because we use an umbrella. It's just an umbrella at that point.
Yeah.
Which I would make the argument, vent until you can't vent anymore. And it's always going to be an umbrella rather than just a little rubber cap that has no brim on it. Like, we're always going to shed water as best we can. Let's find a way to make a modern house with overhangs, in other words. Like, let's not make an argument for no overhangs.
It's one of those things, though. I get it, and I want to agree with you.
But you won't?
Well, I'm not going to totally agree with you, because the architect in me says there is some pretty cool aesthetic value in seeing that perfect cube of a house. Okay, so it might not be my style, but I can appreciate it, I guess. But it gets back to our other points of, if you're the designer or architect on that, and you're going to take the roof and just fold it over the wall and not have any overhang and put the window in the wall, then you need to heighten your awareness of how all of those holes that you punch in the wall
how they're flashed, how they're dealt with, and how they're water managed, so that your intention is proportional to, you know, the consequences available. And that to just sit there and say, oh, I'm not going to put any roof overhangs on there and we'll just let, you know, Joe Builder throw the windows in like he used to do or usually does, then that's failing the system, right? So you need to understand that you need to up your game. And then if you take that house and you put it on the coast, then
Totally different conversation.
It's a totally different conversation.
So we can have, we talked when we were talking about above grade walls, the relationship between the way we approach the design and climate. When we talk about venting roofs or configuring them to have the maximum drying potential, that's pretty much regardless of climate, right? If we can do it, we should do it.
Yeah,
I think so.
I agree. But it's to flip the coin on that though. There are what I would call regional perspectives. Like if you go south, I know a lot of builders in the south that they don't even consider a vented roof assembly. We'll just go up there and blow open sub.
But they'll do a vented crawl space.
But they'll do a vented crawl space. So go figure that. It's like, I don't need to do it in the roof, but I need to do it down in where the ground can communicate with my short basement.
Are there any circumstances where we have to think about possible disadvantages to providing ventilation in a roof assembly?
I mean, there's probably an argument at like places that are laden with forest fires and stuff like that.
Yeah, it's pretty interesting. We were talking about, key people in the industry. And when you and I met Steve Quarles, who's from the University of California, Berkeley, and is now at the Institute for Business, Home and Safety, he's always been looking at that relationship between protecting structures from wildfire and protecting them from water damage. And when he came to Building Science Summer Camp, it was all to work with building scientists on how do we maximize drying potential, but also protect it from wildfire.
All right.
So how do you do that?
Yeah, well, so one of the ways is if you can keep burning embers out of the assembly, then that's the largest risk. So for both walls and roofs, if you provide screening that is robust enough to keep out, it's called brands
like
and
a
embers.
small enough aperture that it's below the burning ember point and durable.
It's the gauge of the wire essentially that is critical in terms of keeping those brands out of those assemblies.
I don't know why I just thought of this, but wouldn't it be pretty cool to do a roof out of ICFs? Like you could build it like an igloo.
Maybe, yeah. I could see that.
Wouldn't that be cool?
I wonder if there's a
so you do like a 60-foot diameter igloo and just keep wrapping
if you
ICFs.
use ICFs and you've done a roof out of ICFs, or if you just see a reason to do that, please comment below.
Yeah. But sorry, it came to mind.
Yeah,
we should always be consistently thinking about ICFs.
So another
integrate them.
great resource for people who are looking to design durable buildings is the work that's been done at the Institute for Business and Home Safety. And
I would assume the Institute for Insulated Concrete Foundation. Yes? Okay.
He made it. He said that, not me.
Weren't you the host of this session and you're drawing us down into
there we go.
insulated concrete
taking
floors?
it to a lowest common denominator?
But let's talk about insulating roof systems, right? Because we can, if we vent roofs, then we're stuck with insulating pretty much on the flat or in the stud cap or in the rafter cavity, right? With having some kind of ventilation above it. One of the benefits that I always see people say, well, why would you do a vented roof? Well, if I'm not doing anything crazy on the inside with volume ceilings, then blowing an R70 cellulose roof is a pretty inexpensive event, right? It's
relatively speaking,
as far as insulation goes. It's like you paid the guy to come. Going from R50 to R70 is hundreds of dollars on a 2,000 square foot.
Well,
house.
and as you say, it's an economic question. It's what it boils down to.
It's an economic question,
and
but it's also
a lot harder to get R70 in the rafter.
And it's a lot harder to get R70 in the rafter. But I have done some retrofits where we've, gusseted down a 2x4 from a 2x8 roof and turned that 2x8 into a 14-inch cavity or whatever the case. So there's ways to do it. It's like anything. If you throw enough money at it, you're going to be able to come up with a solution to do it. But I've also done a roof retrofit where we've gone up on the roof and it was board sheathing because it was an older house. And we basically took stripes of the board out pretty much in about 4 to 5 foot increments. And the roof was totally uninsulated in this house. And then we blew spray foam, closed cell spray foam up and then down in the cavity and basically closed off. It was a shallow cavity, only like 5.5 inches in this house, but we knew we were putting a new roof on and stuff on it. So pulling up a couple of the pine board sheathing.
So it was finished underneath.
It was finished underneath with, the typical like horsehair plaster and stuff. It was an older home that we were trying to retrofit, but it was a pretty neat way. It worked out really great. The builder, the insulator, everybody was happy. It was very successful.
So that was an unvented roof assembly.
We turned it, it was like a totally, let's call it air open roof assembly because there wasn't even insulation in it. And then we closed it down and turned it into...
But then the same thing works. If we do what he just talked about, before we put the roof on, we put on strapping, we sheath it, and then we roof that.
Yeah. And what's key here is that if you're going to eliminate the drying potential, then the air tightness becomes even more critical because you don't have the forgiveness of the vent until you can't, but don't think that venting's going to overcome air leakage, right?
Yeah. Or bulk
that's
water.
A losing proposition.
Or large amounts of bulk water either.
Yeah, absolutely.
If you have a roof leak, it doesn't matter if it's vented, most likely.
Yeah, and I mean, I think you remember, but probably about 2 years ago, I had a project that was a retrofit project, and I remember sending you the photos. It was a 2x12 rafter roof, and it just had fiberglass in there. It had some vent chutes in there, but half of the vent chutes went to skylights, which were an end dam to it. And I remember sending you the photos, and you were like
creating
intrigued
a
because,
loop
right under the skylight where that lateral blocking is, it was all mold. Which it should be, because you're taking all this moist air and running it right up there and to a dead end and feeding it. But the way we solved that was very much, it kind of, this 1 in 12 roof and inspiration, everything comes from experience. In that roof, the way we solved it was we laid 2x4s on the flat. We put a second piece of sheathing on it. And then down at the soffit, we just cut out a 4-inch strip across the whole soffit. So the vent that was in the soffit that existed could now go up and into the upper vented space. We just added another piece of subfascia, but then we were inside the house. We had all the drywall off. We just packed that whole cavity with insulation. And so now we have a totally vented roof on the top side that's very similar to what we were talking. And it's a pretty shallow roof too. It was probably a 3 in 12.
And if you're putting sleepers on the top side in an assembly like that, you could just make a void right at the top,
Yeah, and that one was easy. We did a typical ridge vent at the top. So
that makes sense. So I know we already recapped once. We're venting until we can't. We're choosing our roof design as best we can, and maybe trying to not build in the neighborhoods like Steve was talking about earlier, where there's geometric
architectural complexity required.
Yeah. Which is, God, is that not what's wrong with half the houses being built in the United States? Sorry, everybody that builds in those neighborhoods. If you listen, thank you for being a listener. We respect you. Yes, no overhangs is okay if you're aware of what the consequence of that is, and aesthetically it works.
Well, I think the problem with saying no, don't do that is not really the root cause of evil in that situation, right? The root cause of evil is the ignorance and not doing proper window flashing.
Yeah. And there are tons of buildings.
Understanding that I've just raised the stakes by taking the roof overhang off.
That's the best way to put it. You just changed your risk substantially.
Exactly.
And gable vents don't work because there's no elevation change to create stack effect.
They can work, but they don't work nearly as well.
And they don't work because of stack effect. They work because of cross ventilation, which
you've
could
got
be
a-
fine.
Yeah, absolutely.
We don't care how it dries as long
I
as
think
it
if you
dries.
probably had, like, if you did a tiny house and you're talking about the length of house being 20 feet and maybe 20 feet wide with a simple gable and you put gable vents in, I would argue that we could probably do a wing nut test and that might work. The problem is when you
gonna
see
need a
a
hat.
60-foot colonial and they have a little 18-inch by 24-inch gable vent here and here, 50, 60 feet apart, and they expect that to flood this attic with
What a
air.
great way to wrap up by saying we need to wing nut test gable to gable ventilation. I've never done it. Wow. Let's go. Close it down. We're going to go out and find some gable.
We're gonna go find it,
and
but-
fog it.
I will sit in the car while you knock on people's doors and go, is it okay if I...
If I have my wing nut hat on,
Yeah.
people trust
it'd
me.
be way
We
better.
got
if
this
it's-
hunch that your roof isn't really working properly. Do you mind if we climb up there and prove it?
We're gonna put one of the guys here inside. Do you have an access inside the house that this guy wearing the Marine hat? That's
You can trust
6'5"?
me. I have a wing nut hat
up
on.
there. But hey, one thing that we didn't touch on.
Didn't you
before
see
we
the
close
clipboard?
it down, though?
I have a clipboard. Like,
Hey, I just want to touch on it because I think it's really important. Attic hatches, attic access. Mm-hmm. It's very important. We talked about air tightness, but you really need to consider that. Those are leaky
worst.
as hell, right? So you need to pay attention.
and always under insulated.
Yeah, and maybe we
Let's
can
blow an R60, but use a 3/4 piece of plywood right here.
Batten the hatches,
yeah.
man. Batten the hatches.
maybe in the comments below. I did a beautiful article for JLC a while ago where we did this kind of double hatch routine. I did it with Shoreline Builders, but we did kind of a locking gasketed closure, and then down below it where the finished ceiling was, we just did this little pop-up panel. So you basically popped up the panel, took it down, and then you reached in the hole and the real.
Cool.
Yeah. Same thing we did at my personal house. We got
Exactly.
we got that from you too.
Exactly. So
So, okay.
anyways, all right.
Any other final thoughts?
No, I mean, I won't wear my hat anymore. Thank you for not bashing our military today, but I thank you for that. I know. Hey, all my military friends out there. Jake's not a military basher. I'm just having fun here. Jake loves our
For
military.
all the people that don't listen to the whole podcast, I'm still a despicable human being. Okay,
It's a wrap on roofs.
Yeah, that's the wrap on roof. Thank you for watching today. Thank you for joining us on the podcast. Thank you for joining us on YouTube if you're watching on YouTube as well. If you're on YouTube, click the subscribe button. Don't forget to hit the little bell at the bottom so that you get a notification each time we publish. And if you're listening on iTunes or Spotify, or if you're just listening to the audio version, please go to iTunes, leave us a 5-star review. If you don't think we warrant a 5-star review, you could still leave a 5-star review and just use someone else's name. It's fine. No one cares as long as we get the 5-star review. That helps us reach higher points in the charts, and that helps us show up and find new listeners and find a bigger audience, and that's our goal. We're sharing this so that people get to hear it, not just so that we can sit around and BS all the time, although that is quite a benefit for me. I like just hanging out and recording these. But
I'd like to think I got better things to do than sit around a table with you two.
it's unfortunate that you don't, though.
It's kind of unfortunate.
I don't know if that says anything about
Maybe
us.
I need to reassess my position.
You've been able to sit around with you two, the band? Is that what you've been doing?
Yeah.
Holy smokes.
I think I need to reassess my situation as my position in the universe.
And that's where we leave it. Steve on an emotional journey. Thank you.